Hello and welcome everybody. My name is Corey Lambertson with Asiga, and today we have a very special webinar on miniatures, and I have the pleasure of welcoming Ramon Jahn from DTR all the way from the Netherlands. Ramon, how are you doing today?
I'm sort of feeling fine. How are you?
I'm doing good. I'm doing good. So just so everybody that's watching, just let you guys know, this webinar is being recorded. And if you'd like to watch it again later, it will be up on YouTube here in a couple days. And so please feel free to come back, watch it again, share it with your friends, and try to pick up as many tips that Ramon's going to show today. This is a really cool webinar because we're actually going to get a tour right today. And
Absolutely.
So it's going to be pretty exciting. Before we get started, let's actually talk about what this webinar is on. And so today, Ramon's going to be discussing how DTR, the company that he has implemented 3D printing technology for the production of master models for mold making. The definition of master mold or modeling is a crucial element in the production of miniatures, as it has the direct influence on the mold integrity and casting outcomes, trying to capture all the extreme details. Ramon will discuss some closely kept process information and share his thoughts about when to choose 3D printing for the direct production of miniatures and when to consider a 3D printed master for mold making. He will also walk you through the important preparation stages of the 3D printed master prior to mold making. So Ramon, before we get started, I would love to learn more a little bit about you, and then I think we're all excited to hear what you have and see your presentation.
Well, thank you very much. I will start the presentation soon. To give a short intro, well, my name is Ramon Jahn. I'm from the Netherlands. My company is called Tinnen Roos, but I prefer you call it DTR. It's much easier. And I started this company in 2004. In 2004, we didn't have any 3D printers yet in our company. My first 3D printer was in 2008. It was more started like a hobby, was self-employed. I was always good with both hands. So it means whenever I saw something, I was able to produce something or to model something from it. And since 2008, you can really see I started professional. So I buy my first 3D printer. I did buy a spin cast equipment. Spin casting is for making metal models out of pewter or white metal, they call it. And this company grew. So we did a lot of gifts, pins, these kind of elements. We did a 3D sculpt in that time, or we asked a quote for 3D sculpt. We had a 3D printer, we make the models, we form it, and we are casting it in metal. And this was basically the starting. Since 2008, the company grew. Every year, you can say there was another employee added. Till now, we are more or less with 10 people in the company, and we had three movements in a company from a hobby area to an industrial zone. In a moment, we have a fantastic building in the middle of a center. It's really great. And yeah, we cast not only metal, we cast with spin cast equipment, we cast with cast equipment. This is injection molding in silicone. And for everything that we use, there is one important thing, and that is our 3D print, because that's our basic, that's our start. And how better your 3D print, how better your final product. And in this presentation, that's what I'm going to talk about.
Awesome. Well, I can't wait. This is going to be exciting.
So should have started. Let me share my screen. So hopefully we're all clear. You can see the start of the screen. Fantastic. Here we go. Well, a warm welcome, Tinnen Roos. Well, we start immediately with the build platform with a really cool mini, a gadget for a game called Rollercade. And this is our base. Basically, we start with a 3D print, and during the presentation, you will see that will be a final product. I'm not working alone, and like I said, we work with a team of people. You will see a lot of young people in the company. Mostly after they finish with the school, they enter the company and they never leave. So that's fantastic. It's a craft, what we do daily. So there is a lot of involved with your hands, but also a lot of involved with production, because in total, we make more than 2 million parts per year. And that with 10 people in the company is quite impressive. And every product goes mostly 2 or 3 times in the hands before we can pack it for a final customer. The techniques that we use we start with a 3D design. So either we get from a customer a 3D design, which is sculpted, or we sculpt ourselves in our software. We're using ZBrush or SolidWorks. SolidWorks is more for the technical parts. ZBrush is more for the organic models. And well, you all noticed people have the tablets, they have the pen, they start to sculpt. And mostly in a day, there is an organic 3D model.
Do you like using the pen technique with for your CAD design?
No, for the CAD design, not. For the CAD design, I just use a mouse and metric tool. So, and also I use the CAD design. So when it's about technical parts, I can build a building or I can make a bridge. But when it goes to organic pieces, we have a sculptor over here called Eduardo, and he can sculpt everything just out of his hand.
Yeah, that's amazing.
Yeah, absolutely. So next step, the 3D printing. And I'm very proud to say we have two 3D printers. We have the Asiga 4K 45 and we have the Max X30 385. And both printers, sorry, it's the Max X35. It's a UV 385. And both printers are fantastic in the level of detail. And I cannot say it often enough, but I still think in the corner you can see a little bit, but if you see these kind of little details, I hope they're a little bit sharp. And then if you know how thin they are, probably you can hear them snapping.
Mm-hmm.
But still, it's a fantastic print. It's almost finished for molding, almost, because you can never get a product, get it out of the sprue and just directly mold it. We always will send it a really tiny bit before we mold it. Molding is the next step, mold making. We use a Nichem, it's a company in Italy who makes spin cast equipment. We use a vulcanizer. And in this machine, we vulcanize silicone molds. And between the layer of the molds, there are the 3D prints.
That's pretty wild.
It is. So after the mold has been vulcanized, it's more or less 2 hours of work. It's in the oven. It will be pressed. The silicone will be cured. And after the silicone is cured, it's very elastic. So we can open the mold. We take out our model. Then we cut our gates. And either we go for injection molding in the seal cast system, or we go for spin cast on a Nichem spin cast machine. And both techniques at the moment are used pretty much in a factory. That's basically all we do. We print, we cast, and we deliver to our customers. Not always. Sometimes we choose, we just print, and we don't even cast. Let's assume a customer just needs 80 pieces, like I have here on the picture. It's an amazing picture, isn't it? 80
Isn't
pieces
it?
printed, yeah. And mold casting, molds, of course, have its own cost. So when we produce a mold, it is more or less 300 euro. And if a customer just has the demand of 50 or 80 miniatures, sometimes the cost of making a mold is more expensive than if we just would do production printing. So for a lot of Kickstarters or small quantity levels or some special stretch goal that they have, they only need 50 minis. I would always advise just print your models and don't even mold.
Yeah.
But from 100 models, still a range of 10,000. That's where the casting process in silicon is very, very interesting. And it's very cost effective. It's even much more cheaper than injection molding in steel molds, because the steel mold is very, very expensive. And if you go for more than 10,000 models, then we start to compete with them. But below that number, you're always cheaper in molding into silicon molds. Did you ever see how models have been, or how parts have been molded? Did you see this before? No? Well, here you can see a mold. This is a product we are now in a moment, starting to produce for Olmec Games. It's a company in the UK. Previously, we did this in metal because the metal prices are really raising at the moment. We are transferring everything from metal to resin. It's made in a seal cast machine. And what you see over here is a yellow mold. The cost of this mold, that's what I told you, is more or less 300 euro.
Wow.
But I can do 30 shots per hour with this mold. So
it's
can you imagine how many
effective.
pieces we can make?
Yeah.
Same thing is with the spin casting. With spin casting, we use a machine which is rotating, and by the centrifugal force, the metal is going from inside to the outside. Or for that also we need molds. So for this picture you see a model of strata miniatures. It's a model for Dungeons and Dragons, and I have a small video about it. So first thing we see are the 3D designs. So the 3D designs have been made ready. The next step, I will just pause for a moment, are the 3D prints. So the 3D prints, they are already printed on our Asiga. After we printed them, we clean them a little bit, meaning we undo the sprue, and with some really fine sandpaper, I have it in the workshop, I'll show it later. With really fine sandpaper, we, from a Korn 1000, we make it ready that there is no printing lines available anymore. To be honest, with the Asiga, you can barely see any printing lines. But if there really is a flat, smooth surface, we just scotch it a little bit.
Yeah.
Then we take a releaser, and the releasing agent is something that prevents the resin mini to stick to the silicon during vulcanization. So the first mold that we are making is a master mold. A master mold is for making multiple copies in metal to make production molds. So first we are producing our master mold. When the master mold has been vulcanized, we undo the piece from the mold, we cut our gates, and then we will spin it 10 times in a special master mold alloy. It's very brittle, but very, very detailed. It's called tin with bismuth. And it's tin with bismuth, we spin it 10 times. And then we subdivide all those pieces to different production molds. Some production molds are square. They're made for the Asiga or for the seal cast system. And some molds are round for the spin cast system. And as you see, it's a craft. So people working with their hands, pushing into the silicon and putting the part line where they want. Also, you can see different kind of colors they are using in the silicon. And that's because the silicon has a shore, has a hardness. And sometimes for flexible parts and high undercuts, you need a softer silicon. Well, during the vulcanization in about 2 hours, the mold has transferred from the soft silicon, which you can still bend, to a strong elastic silicon. So it has been vulcanized. Well, you can see that all the minis are in the mold at the outside. And all the metal masters that we have created, we take them out, we cut the channels, and we start a production. By spinning the metal, letting it spin for 2 minutes, and after 2 minutes, we undo the pieces from the sprue. We fold the sprue, and this is what is really nice, is we remelting it. So everything we don't use, we can 100% recycle it. The same thing is with the seal cast system. So also here we have vulcanized the parts. The seal cast is injecting the plastic to the mold after we undo the pieces from the sprue. So these are all bases, 16 bases, and then with 30 shots power, it's pretty an impressive production, what we can do. With a mold of only 300 euro and a lifetime of at least 500 shots.
Wow.
The next step, we take a shredder. Oh. I pushed the wrong button.
Gotta love technology, right?
It is. It is. So it's a quite important message what I want to say here. It's we use the shredder, and with the shredder, we can reuse the plastic again. So everything we don't use, we're remelting it, and you can see end of the day, 5,000 pieces nicely presented on a table, ready for packaging. This is a model for Strata Miniatures. It's a really nice company with really a lot of details made for the Dungeons and Dragons diversity. It was really a cool project to do. Well, after people can have their fun with painting, of course. So in the video, you saw a lot of elements, materials, and to be honest to you, I just like to share. As a company, I don't have much secrets because I believe when you share knowledge, it will be better for everybody. So
Right.
the materials that I use with the production was first of all the 3D prints. When you buy your first Asiga printer, you can always choose a material, and at that time we choose the Asiga Plus Gray to start with. So some of our models we're still producing with the Plus Gray. But there are also materials which are really engineered for miniatures. One of them is the Amira Labs. It's called the TGM7. If people want, they can take a screenshot from this because it's a lot of information. If you need to Google this, it will cost you probably days. And now you have everything in one sheet. And well, just ask them a question. What I like about this material, we use this a lot for production printing because it's very flexible. First of all, I have here the sprue with the 80 minis. And as you can see with my fingers, I'm really going to bend everything without it snapping off. The 3D printing resin from Excellent Resin, that's the one I'm using when I just make metal masters. So I just need one print, and this print material is very crispy. Probably you can make the thinnest supports as possible. We make a support like a 0.16 millimeter as a touch point.
Wow, that's insane.
And with Excellent Resin, it's possible. So after you can really just, yeah, you can hear the voice, you snip them off and they're almost ready to use. But when I form this into a mold, it could happen. Then when I take them out of the mold, they can snap. So because they will be heated in a vulcanizer with 90 degrees, and the force of the silicone, when you take them out, probably they will snap away. So you can only use them one time, which is not too bad if you make a prototype mold, because you will make metal masters anyway. But if you want to make a production mold and you want to make new molds all of with the same models again, then I would advise the Amira Labs because it's very flexible, so you can reuse it.
Yeah.
For the metal, what we use in the company, just send me an email and ask me. We use an tin bismuth alloy for making our metal masters. And bismuth is a very, very nice material because it's expanding from liquid to solid. So when you have this model into your mold and the model is casted and it starts to cure, so it has to be solid, it expands a little bit. And normally you get some shrinkage, but with making the masters of tin bismuth, there is almost no shrinkage at all. Then we have a production material we produce with a lead-free tin alloy. It's the most common alloy for making metal miniatures. It's tin with a little bit of copper and antimony. The silicon we did use in the video was some green low temperature silicon. It was also we use a little bit of yellow and some orange. The orange was to make it a little bit more softer with high undercuts. And well, the fantastic thing with CO casters, this system is now on the market since 2020, and we're getting away from resin casting by pouring resin by hand, is what we did previously. Now we're making injection molding into a silicon molds, and if you have any questions about it, just give a call to them. They are located in Spain. It's a fantastic company. Yeah, next page. More about the resins. So the Excellent Resin, again, is using for just single models. I vulcanized them one, but the models are very crispy and the support is very thin. For production models, I always can advise the product from Amira Labs. Asiga, well, I'm a fan of you guys. Let me just say that what I really love is that you're open source. That's the reason why I choose for Asiga and also why I choose to, well, ask to be a reseller of this brand, because it's fantastic. You make really the most, I think it's the best of the machines that are available in the market. They're still affordable. And if you can see the print quality, what you can produce and all the technology that's inside, I really love it. I would also love your software to make the support. You're still starting to improve it. Most of the people would not think that this has been supported in a composer software. It's a software of Asiga itself, but I did test it. This is the beta version, so probably all you guys will get some we'll get this software very soon in an update. And this morning I asked to Graham if we can show it, but we can show it. So this model, what you see over here, is auto supported.
Yeah.
So
and it should be released here in the next, I just heard word it should be in the next few weeks. And so we should have it officially available.
Fantastic, because what it basically does now, the support structure, it creates a mesh around the model, and it's a different kind of support than you did see before. And normally for a platform building, I spend minimum an hour to put all my models in the right way, and this really saves my time. What you see in this picture maybe cost me 15 minutes. So it's really a time improvement. Well, you can also see it on the next picture. For the people who are already using Composer, you have an extra list with some more gadgets and tutorials. This is the tank. It's an old World War I tank. We did produce this in Mel for a company called Game and Biz. And well, it's supported already on the new software. And if I show the result, you can also see how small and tiny things are, because it can look really big on the screen. But well, this is a water drop. So just imagine how small this piece is.
Right.
I want to go one more time back to the Composer. What I also really is fantastic that sometimes you have a misprint. You try it, you want to go for the max, and sometimes you miss it. Well, then you can select a point, and you just at that point you will add a different number for the thickness. That's really a cool gadget. Yeah. Okay, back to the tank. So tank is casted from a white metal, pure tin, lead-free. It's the same as a train. You know, we started with this picture in the beginning. And well, what's the name of this animal in English?
We call it a ladybug.
Ladybug, yeah. This ladybug was landed on my miniature, and it's just to show you how small things are and how lovely the details are. Without an Asiga 3D printer, I couldn't make these kind of details.
Wow.
Also, this is quite a complex model for casting, because you can look through the windows, and if something is really difficult for us, is looking through a window and still be able to cast it. So we use inserts in our molds. For the people who like to see something about molds, first we 3D print our model that you will see on the first picture in the right bottom. Then we make a silicone insert. Those models with a silicone insert we form into the molds. Then we vulcanized, and then each casting we placed its inserts back. And because each insert is made by hand, you will see also in the right picture above that the inserts are numbered. So number 1, number 8, number 9. And each casting we put the insert into a mold, we cast, we pull them out, and we put the insert back. It's time consuming, but well, the result is there, isn't it?
It's amazing.
Well, let's go live to Mike. As I promised, we are casting at the other side of the facility. If you want, I can show you the workshop. I will switch from this camera to my mobile phone. So let me see if the technology will help us. First, I will log in.
This is exciting. I can't wait to see your facility, and especially since we're going to see the injection process live, correct?
It is. We're going to basically see this model produced.
Yeah. And just for all of our viewers, as we're getting set up for the road show, if you guys have any questions in any way, shape, or form, feel free to send them over. And while we're going through, we can ask them live as well.
Recording in progress.
Looking good, Ramon.
It is. Cool. Are you attempting with this cell phone now?
Yeah, it looks good.
Okay, fantastic. So let me switch the camera. Here's Mike.
Good evening, everybody. I'm here to show you some production work at DTR. But first I'm going to show you the spin casting. This is the silicone mold I'm going to cast. So, we put the mold in the machine. Now we have to wait for 1.5 minutes, and then we have our minis.
1.5 minutes. Let's go to the commercials.
Yeah. So Ramon, we did get a question that came through, and the question was, how do you approach design for 3D printing? You know, what do you consider for like overhangs or wall thicknesses or supports, or do you not have to consider that with an Asiga? What do you see as the biggest concerns?
Well, for me, as in a company, it's the castability. So it's not if it be, I can print everything, but I cannot cast everything that can be printed. So the printing has less limitations than the casting. And with a casting, with a big piece, for example, we need a wall thickness from 1.6 millimeter. But for a small piece, we can sometimes go to 0.8 if it's just a small piece.
Yeah.
But and it also depends on which metal we are using. But for example, we are now producing with the normal production material. After, when you see the casting, you will also see this material is very bendable. The next shot that we're going to do will be with a tin bismuth alloy. I think if we would stop the machine.
5 seconds left.
Okay. So inside, the metal is from liquid to solid. And you can see the surface is,
Wow.
yeah, it's still a little bit hot, but my fingers are dead anyway.
And that's a mold from a 3D printed part.
That's a mold from a 3D printed part, absolutely. So we pre-supported it with the Composer software. We designed it in ZBrush. Then we make a mold and we cast it. And as I can say, we can go for 30 shots per hour with 16 minis inside. It's really a massive production. And that's not the only material you have. So one of the materials was this, is the tin bismuth, is the tin alloy. It's 300 degrees warm. We have also a material which is a little bit more, it's even better fluid. And I use this for the master material. It's a little bit softer. It's called tin with bismuth. And let me also do a casting in that material. So Mike will put the mold into the machine. Never record and cast at the same time, isn't it? And tin bismuth is basically a mix of two ingredients. One is called tin, the other is called bismuth. We mix them together, and the bismuth is very, very fragile. So every model of tin bismuth, you can never bend it. If I would bend it, this is normal tin. Normal tin, I can completely bend, it will never break. If I do this with tin bismuth, it will snap away immediately. And again, I really like that this is happening. You can just remelt everything.
Wow. You know, it's pretty amazing to see how much you can recycle at your production, you know, just in production in general. So all of your scrap gets recycled.
It is. I hope you can have a little bit of a clear view.
Yeah.
So this is our normal production quality. When we deliver a miniature to some other customer as contract casting, this would be the general quality we deliver. And again, all the level of detail has been started with the 3D print, then with the way how we are making the molds. So everything what you need to do, you need to take care of it. And everything we don't use. So Mike will open now the mold with tin bismuth. And tin bismuth is You can see the color. It's very matte, I would say,
Yeah.
but it's very, very crispy. But crispy also means very brittle. You can see they are snipping off. You can hear the sound probably. And also this is very strong, so I cannot bend it. And while the reason why I can bend it is because of the bismuth alloy. It's very strong. So all the tin and tin bismuth production, this is running all the day. There are 2 girls just producing all the day. I'm making mold for it. The next step will be the seal cast system. Heb jij de mal van Jos klaar? Je hebt al putsch gedaan?
Ja.
Fantastisch.
Nee, net liep hij wel niet goed.
Ja, Oké, moet je even happy talk ertussen?
Ja.
Oké, so wait 1 second. Vraag even Mike.
Uit de mold. Put it in the machine.
Can we first see the mold for a second inside? So there are 16 pieces inside for 4-piece model. So we will cast 4 miniatures in 30 seconds. So we can hear now the machine is running. I don't know if you can hear it, but we can hear the casting.
Yeah.
So the material is already injected and at the moment it's cooling. And the materials that we are using is this mixture, which is in a melting hopper on top of the machine. It's some soft plastic, a mix of hard plastic. Then we have a color to make it gray, but also you can choose to have other colors. And then we have a recycled spruce. So when we have a sprue of a miscast or something we don't need anymore, we shred out this piece, we make it into this fine granulate and we mix it back into our alloy. And this alloy, oops, machine is already ready.
Oh, wow.
Well, Mike, here is the sprue. It's still very hot, so we need to let it cool. But can you imagine if we make a cycle, for example, with 9 molds in a circle, and we do, well, at least 30 shots per hour. It's an impressive production. Let me get you another mold, which we also have produced. 1 second, please.
Yeah.
So this mold, we just take a shot of that one. And you can also see that you have highly pieces with a lot of undercut, which is still, this is impossible in a steel mold. But because of the silicone is flexible and, well, we're pretty good at mold making, this is the result. So to show you the rest of the facility, so seal cast, engraving department. We're Dutch, so you know we love orange, isn't it? All orange. Some big trophies. And an antique finish. So after we've molded, we cast it, we give it an antique finish. And same thing with coins. Let me just get one of the coins in my hand. Can you still hear me?
Yeah, absolutely.
Okay. Can you see how smooth the surface is? And how small the letters are, the little details. To be fair enough, this is printed on an Asiga. Well, this is a production of today. It's produced for freebooter miniatures. So after we have done a production, we undo the pieces from the screw, and we always put them mostly 10 by 10 to do some quality control. Because sometimes we can have a miscast, and if we have a miscast, we just pick a model, we take it out, and we replace it with a new one. Well, here's the room where the magic happens. They work even overnight. Great, isn't it?
So when you, okay, never mind. Which printer is on the left there and which printer is on the right?
This is the 4K machine. And this is the Max X35. And maybe you have noticed I have a separate room. So there is the production facility. And here is my 3D printing room. There's a reason for it. Let me just switch my camera. When you have a production company where you use talcum with casting, you make a lot of dust. You don't want this dust in your 3D printer. So here we have all the extraction in the factory. And here we have a very, very clean room. And we want to keep it this way. So all the dust that will be collected will always be put it in this direction and never going to our 3D printers. I think you also know this is the most important thing, is to keep your 3D printer clean and don't put it in a dusty area.
Yeah, absolutely. That's the most crucial aspect. We had a couple of questions come through, and so one of the questions that we had, and I think you were going to maybe show this, and I think we're maybe getting to it right now, is how do you make the surfaces on your miniatures so shiny and so smooth?
Okay, first of all, it's the surface quality of the metal itself. And I didn't prepare this, but I will ask Mike, kunnen we toevallig iets scotchen, een muntje of zo? Ligt misschien erin. Okay, we will just make a coin, okay? To answer this question. Die is gezuurd, er ligt een gezuurde munt. Because the surface quality of the metal when we're casting it, how better the surface quality is, how much easier it is for us to clean our product. Cleaning a product means after the casting, we undo with a Scotch-Brite. This is turning, we undo the surface. Then with an acid, we make our metal black, and then we scotch it again. So this coin, yeah, this is already a coin casted, and with some acid, it's now black. The next step is scotching. So probably this is an answer in your question.
Wow.
So let me go back. Also, what I think it's important when people are using the alcohol to clean the product, because after the 3D printing, you need to clean with alcohol. And please always make sure you have extraction. Also for the people who are printing at home. It's important. Wear safety glasses. Put some extraction. Open your window. Make sure that your air is clean. I see a lot of people who are not using it, and it's, my opinion, is one of the most important things. So I will go back to my desk, but anyway, you had a small impression about our company, what we are producing.
It's phenomenal. So we did have another question come through, and that next question was asking, how does the digital process compare with traditional mold making? What are the time and cost savings that you encounter?
Okay, wait 1 second. I'll switch to my PC.
Yep.
So before 3D printing, there was hand sculpting.
Yeah. So you would have to make all of those devices by
Wait,
hand
one second.
previously?
Now I can hear you. I couldn't hear you. So before the 3D printing, there was hand sculpting. Is it the same? No, I think traditional hand sculpting, there are still artists who just in our company who they deliver us the model. For example, for Freebooter's Fate, it's a game from Werner Glocke. He still sculpts the models himself with green stuff and then send the green stuff models to us. It's very old school, but it's very, very classic. And sometimes you cannot not even compete digitally. But most of the times I would say now digitally wins, because if I want to print if I want to produce 3 different sizes, so let's assume you make a trophy for place number 1, 2, and 3. You just can print 3 sizes and that's it. With hand sculpting, you need to sculpt it 3 times. So you will save time. Also in making a model, I think a good sculptor will produce a tabletop mini in a day with sculpting.
Thank you for answering the question. We had another one come through. And it says, is there some place with good information about design of miniatures for casting from a casting company perspective, perhaps? Precise measurements, calculations, draft angles, etc.
Yeah. So most of the answers, we get a lot of people who just send us the models, which is not castable. In-house, we offer a casting service where the people will pay us a little fee, but we adjust the model and make sure it is castable. And what is adjusting model? It can mean when an arm is in this direction, we need to cut up the arm to make it castable, and people will glue it after it's been produced. Or we will bend the arm back, make it a little bit thicker. Sometimes we add some elements. There are companies who are able to do it, but they're not always there. You need to search for them.
Yeah. So if somebody wanted to get into the miniature industry and for mold making and just this overall industry, how does somebody get into miniature? Is there a school for it, or do they just start like an apprenticeship, or how does somebody get into this industry?
Well, for the spin cast and the seal cast, we provide trainings. Also, a lot of time we get hired by Nichem or by seal cast to provide the trainings. There isn't really a casting school. However, I think what's closest is probably going for custom jewelry. Jewelry, there is some education. This is possible to learn a lot about it. But for the rest, to be honest, it's just a lot of practice. Just make your hours, make your days of practicing after months, after years, and how more years are passing, how better you will get your results in mold making.
Yeah.
Should I share my screen? And you can still ask me so much questions as you want.
Sorry, everybody was getting excited, and so I didn't want to leave them hanging.
So we saw how this mini was produced, and so can you imagine for us how easy it is to cast 80 models once the mold is ready? But till the mold has been made, there is some time. So sometimes with just 50 pieces, we decide let's go for production printing. But again, from 100 models, we take the time, we make a mold, but from that moment we're pretty fast. Well, a training, that's maybe the question of an answer to your question. When we provide training to other people, it can or be in our facility. So in the right corner below, you see a company called Tinnen Roos. They already have been in my facility 2 times. They're from Poland. Well, we teach me how to make molds in our facility. So we have our 3D printers here from Asiga. Everything that a miniature producer is dreaming of, it can start over in this company because we have all the equipment and the machines. But during the Corona crisis, we of course couldn't travel. And for example, in the left corner below, there was a Reaper Minis for the first training that they had. We have given some training in Australia digitally. So it's fantastic. So I'm here with a camera, I'm making a mold, and then people are copying me at their location, and step by step we are making a mold. It is also working. And sometimes I travel. For example, 2 months ago, this was in Reaper Miniatures in the United States, and together with Reaper Miniatures and Talent Games, Well, we provided training over here, and as you can see, there are multiple seal cast machines, and was a fantastic team. Our company, so our services, we do contract casting. So if somebody wants to have a miniature produced or printed, they can just give us an email and contact us for 3D printing or for training. My customers are also most of the time in the miniature, food industry, technical parts, gifts, but most of all, we never say no. So we get a lot of questions from a lot of customers, and we're just trying to make it. When we provide a training, somebody, if they didn't buy the equipment, but they want to have a training to get started, they're always welcome in our location. And again, we are helping people business to business, but also business to consumers. I was a consumer once in 2004 and I want to get started. And also I found people who helped me. So I think it's my next step to help the other people.
Absolutely.
Well, if people want, they can make a screenshot. You have all my information. If you're going to call a company, please know we are in the Netherlands. So here it's now at almost 10 o'clock in the evening. So don't call me 3 o'clock in the night. But for the rest of that, you can email me, you can WhatsApp me, Skype, whatever you prefer. We have some social media where you can follow us. So that's all fine. But I'm looking forward to answer some questions for you.
Absolutely. Well, thank you so much, first of all, for the presentation and the tour. It was phenomenal to see your facility and your guys' workflow and actually being able to see casting live. I've never seen the spin casting process. And I was sitting there thinking about all the different objects and toys that I played with throughout my life. And it made me think to wonder how many of those objects were actually spin cast. And so a couple of questions that we have is, the first question we have is, did you ever try making miniatures with metals like steel or titanium? And, you know, what are the complexities when you try a different metal like that versus like the tin-based metal that you're currently using for your spin cast?
Can you please repeat it? Because I was just switching with my screen.
Oh yeah. So we had a person ask, have you ever tried making miniatures with like steel or with titanium?
Okay. The thing is, we have a melting temperature, and the melting temperature of a tin alloy is more or less 230 degrees. With 230 degrees, means we will cast at more or less 300 degrees. The silicones are durable till 500 degrees. The titanium and all the brass and all the materials are much higher than 500 degrees. So we can't. I wish we could, but we can't.
Yeah. Yeah, it would burn up the mold.
It will burn up the mold. Yeah, absolutely. So for that lost wax, you can also use this with the Asiga. So we have this Asiga has this material in the program for jewelry, and it can be used for lost wax. So they can print something, and then with the lost wax method, you can cast it. But this is not what I'm provided my factory.
Yeah. Thank you for the answer. The next question we have is how much does the whole complex of this I guess the Cioris cost? This is the vulcanizer, recluser, and then the casting machine. They're just looking for, I guess, an estimate on how much that system would run somebody if they wanted to get into it.
Well, it's not a complex question, but I hope he take a screenshot of the seal cast machines. For that, you need to have a personal quote. But to give you an estimation, if you prefer to drive a Tesla, you can also choose for that option. But I don't want to drive a Tesla. I want to have a seal cast machine. But they are luckily they are high level in the price, because there is not a lot of technology inside. Plus, it's very new. It's just since 2020, and I'm very glad that they have entered the market, because again, the metals are going so high, and I don't know where it's stopping. And I was even afraid for my company what to do. And previously, we were doing hand pouring resin. I don't know if you noticed, two components resin. You need to mix them together and pour them in a silicone mold. This is really a dirty job, and your mold will be destroyed in 30 shots. So going to a normal mold with a lifetime of 500 shots, my life is just much better since we have the seal cast.
Yeah. That's great. We had another question come through, and it was referring to the stack that you had. So you had that stack of multiple miniatures. How long did that take to print, and what material, how long did it take to print, and what layer thickness was that printed in?
I can share that. 1 second, please. Going back. So probably there is something in your corner, in your below. But if you would move this a little bit, then you can see it's a build of a 32 millimeter model, 80 models with the Asiga 4K, and the time, I need to move this one a little bit, was 21 hours.
Wow. Okay.
It's a long print, and we are using some material over here. But if you go off in a weekend and you let the machine run, then it's fine. But normally during the day, I would better choose to make one single layer. After you 3D print it, you just remove it and immediately do another print. So you'll save some printing material. The printing material, what we have used over here was a TGM7, the flexible.
That's great. I mean, it's great to see, you know, how versatile it is and being able to do the stacks after hours. And, you know, like you said earlier, the machine, you're allowed to put it to work after hours. And so it's the only employee that you'll hire that won't complain to work late at night. We had another question come through, and it's this person asked, have you tried any other resins for 3D printing? So you showed the 3 that you use specifically. So have you tried others? And then are there other options that work well for detail or cast, or for cost, or for castability?
Yes, we did. And of course, a lot of customers always also send their 3D printed resin to my company to make a mold out of it. So they will save the cost in 3D printing. So I don't do the 3D, they will send me the physical master, which they have 3D printed. But then I have to warn you, a lot of time the products are sticking to the silicone because they are not well cured. The reason I just work with 3 materials, they have everything what I want. The plus gray for the bigger models. I use excellent resin for just the master material when I make Bismuth masters, or the TGM for the production material. And the reason is I know exactly what's the time, what's the light, what I need to do after with curing. You know, you can put it 3 hours in the sunlight, but also we have a curing machine with the UV light inside. I know that the releaser will not react with the resin. It gives a very thin layer, so I don't screw up my mold basically. So yeah, there are a lot of different materials, and people are free to use it and test it. And there will be a bunch of good materials, but not every material is very good for molding. So that's our limitation. That's the reason we use those 3 materials, because we know that with those 3 materials, we can basically do everything.
Yeah. Yeah. When you were showing the mold making process, you highlighted a separating agent that you dip the printed part in. Are you able to share what that is, or is that your guys' own special? Okay.
When you're in Europe, you can ask Nichem or Silicone. So Nichem are the Italians with the spin cast equipment. Silicone are the people from the injection molding machine, and they are located in Spain. They both have these kind of releasing agents. When you're in the US, I forgot the name, but if you would Google it, release agents for silicone molds, you will find it. It's a liquid. You need to shake it. You dip your model in, you take it out, and it's protected. Okay. And they can send me an email, because I don't know it in my head, but I have written down somewhere. There was also a brand in the US.
Yeah, that's great. So we had 2 more questions that came in, and it says, at what quantities is it worth to go from 3D printing to silicone mold process? So instead of, you know, just 3D printing the end use parts or the end use miniature to actually making the duplicates. And I think you showed that in the beginning.
Yeah. 100 pieces in general, let's say 300 euro. So is the 3D printing less than 300 euro, you go for the 3D printing. If the 3D printing is reaching the 300 euro target, better switch to molding, because after your mold have been made, we can make 500 shots.
Yeah, that makes sense. And then the final, or one of the final questions we have is, have you tried other printers for production?
Yeah. Yes, we do. So I started with the Stratasys Dimension when in early days. Then we tried the Formlabs, the 1, 2, 3. Then we had a lot of experience by people where we subcontracting with somebody else. I always ordered the prints from an EnvisionTech. And to be honest, the EnvisionTech prints were superb. They were good. And then a lot of people also with the, I don't say it's a cheap, it's not fair to say it's a cheap Chinese resin printer, because it's good to start with. And I can really, when people want to start 3D printing, just buy one, test it, and just go ahead. But you will see that it will give you some limitations also in durability. The problem with 3D printing, you need to make sure that you enter the company in the morning and your 3D print is ready. And I can just say, from all the brands, Formlabs didn't got the detail. There was EnvisionTech got the detail, but in my opinion, it was too expensive. I couldn't trust all the resin printers from let's say China who are on the market right now. And when I found Asiga, it saved my solution, because it's affordable and it's a very, very good quality, which you really can compare with the 3D prints from EnvisionTech. And I'm not here to put something down or put a brand down. I love them all, but yeah, I love Asiga the most because they make a fantastic printer and they are open source. So I can choose whatever material I want for my 3D printing. And that's really a big plus.
Yeah, absolutely.
And I think you feel the same, isn't it? Because you are Asiga.
Well, I'm slightly biased, I'll admit. So there, in the different technology of printers, we see that there's 405 wavelengths that we'll see in like the Formlabs and the LCD based style printers. And then Asiga, we have the UV, the ultraviolet 385, that ultraviolet spectrum. Can you speak on how that performance in that different wavelength has affected your quality?
Yeah, the models get more crisp. So when you see a model from the other printers that you mentioned, the model looks good till you see the model of the Asiga and you put it next to it, because also the other models probably will not have any printing lines, or they're very, very smooth. And you think it's a really good quality till you compare it with the print of a UV from Asiga, and then you see the difference. Then you see it's even more crispy, and all these crispy details we can copy into silicon. So that's the reason we just want to get the best resolution as we can. Also for me, when a printer is running 2 or 3 hours longer than normal, I really don't mind, because for me the final product is to make the perfect mold. When we do a production print, yeah, then I will put the resolution a little bit higher. So instead of printing on 0.013 each layer, so 0.013.
So that's 13 microns.
13 microns, and it can even go lower. I can even go less to 10, but with my eyes, I couldn't see the difference.
Yeah. So
I test them all. So in a master mold material from the excellent resin, I use the setting 0.013. When we go for production printing, because I want to speed up a little bit, I'm using the 0.17 till 0.19, so 17 or 19 micron. When we go for bigger models, I don't have a bigger model here, but when we go even a little bit bigger, like the statue, then I will print on 25 micron. But I never go more than 25 micron, because I'm not the company. I'm not there for speed. I'm here for quality, and we put speed in our production.
Yeah, yeah. That's fantastic. Well, I think that's all the questions for now. Thank you so much, Ramon, for all the answers that you gave to all these excellent questions. Thank you for the tour of DTR. It's been phenomenal to see your facility, to see the prints, to see your process. Once again, if anybody has any questions, they can reach out to Ramon directly. He shared his email address. And also, if you have any email or any questions for Asiga, you can reach us at info@asiga.com.
Fantastic. Then I would say have a lovely day over there. Have a lovely evening, guys, and see you next time.
Thank you so much. We really appreciate it. And thank you to all that has watched.
Thank you. Bye-bye.